Once you transport your scope back to your station, remove the dust cover, fold it up, and place it in an out-of-the-way location to keep your workspace uncluttered. Whenever you transport your microscope, you want to make sure to hold it both by the neck and the base. This scope has a nice handle right in the neck, and then have your other hand beneath the base. Depending on the type of scope you have, you might need to plug a loose cord into both the scope and the outlet, or if you have a scope similar to this, the cord is attached to the microscope and you just need to unwind the cord and plug it into an outlet. Compound light microscopes typically have an on-off switch in the base. This switch lights up when I have it turned on. Understanding how to adjust the amount of light that's shining through your specimen is an extremely important skill to have. Too much light and your specimen can be washed out. Too little light and there's not enough illumination to see it. Adjusting the light allows you to manipulate contrast. That's the difference in the visibility of your specimen versus the background. Most compound light microscopes have a dial that will adjust the light level from the illuminator in the base. Another way that your scope allows you to adjust the amount of light shining up through the specimen is through manipulation of the iris diaphragm. This mechanism is located directly beneath the stage, and you twist it to open and close the iris. A mechanical stage is a very handy feature to have on your scope. You can place your slide into the slide holder and then adjust the position of your slide using the coaxial adjustment knobs, usually hanging off the side of the stage. This way you can center your specimen very easily. The focus knobs raise and lower your stage, and the vertical position of your specimen is what determines whether it's in focus or not. On this scope, the coarse focus can be adjusted by turning the part of the knob that's closest to the body of the scope. The fine focus can be adjusted by manipulating the outer portion of this knob. Doing so fine-tunes the image of my specimen. Compound microscopes have either a single ocular lens or a set of binocular lenses. The ocular magnifies the specimen 10 times actual size. The objective lenses are located on a rotating nose piece. Each lens hangs down from this nose piece and can be turned and clicked into position. The shortest objective lens is called the scanning power. It has a red band around it and it magnifies the specimen 4 times actual size. However, since I'm always looking through both the ocular and the objective to view my specimen, I multiply the powers together to get my total magnification. So the ocular magnifies 10 times, the scanning magnifies 4 times, meaning at scanning power my total magnification is 40 times actual size. The next objective lens is the low power lens. It has a yellow band around it and it magnifies objects 10 times actual size. So the total magnification when using my low power lens is the ocular, which is 10 times, multiplied by the low power lens, which is 10 times magnification as well, for a total magnification of 100 times actual size. Now when I switch to the next objective, it looks kind of funny. The lens is covered up with a finger cot. In the lab where I teach, these scopes are primarily used for microbiology classes, and in micro we're mainly using the oil immersion lens, the black and white banded lens, for viewing at high power, and the oil used with this lens can damage our high dry power lens. That's why we cover it up. But for now we need to uncover the lens and take a look at it. I can dispose of that finger cot, and now I can see my high dry powered lens. This lens magnifies specimens 40 times actual size, but again I'm always looking through the ocular and the objective at the same time, so my total magnification at high dry power is 400 XTM. Compound microscopes typically have 3 or 4 objective lenses. If you do have a fourth lens, that would be the oil immersion lens. It has a black and white band around it. It magnifies objects 100 times actual size, so together with that ocular lens of 10 times magnification, I can get a total magnification with oil immersion of 1000. An important warning: whenever you are using your high dry objective or your oil immersion objective, these are your two longest lenses, never, ever, 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 ever adjust the coarse focus. When you're using these longer lenses, you're only allowed to use the fine focus, again, that knob that's set within the coarse focus knob. Manipulating the coarse focus when using these longer objective lenses will at the very least take your specimen out of focus immediately, and worst case scenario could smash the lens into the slide, damaging the microscope. When you're all done, it's important to put away your scope properly so that it won't get damaged. You do this by making sure that the shortest objective lens is pointing down, the scanning power. Then you dial the coarse focus down all the way to lower the stage as far as it can go. This way we know that the lens is not going to smash into the